You ever wonder how a massive website, say an e-commerce giant on Black Friday, can handle millions of people all clicking buy at the exact same second without just imploding? Well, the answer is this incredible, kind of invisible piece of tech that basically makes the modern internet work. So today, we're going to pull back the curtain on this master of digital traffic control, the load balancer. To really get why this is so important, let's just imagine for a second. Let's say you build a new app, you pour everything into it, and boom, it's an overnight hit. We're talking viral success. I mean, that's the dream, right? It's the best problem to have. But suddenly, you're not just dealing with a few friends trying it out. You've got thousands, maybe millions of people all trying to log on at the same time. Every single one of them is hammering your server with requests. So what do you think is going to happen to that one lonely server trying to deal with that absolute tidal wave of traffic? Yep, you guessed it. It gets totally overwhelmed. It chokes. And then it just crashes. Down it goes. And all those excited new users, they get nothing but an error message. Your huge moment of triumph just turned into a total disaster. And that is the very problem that load balancing was created to solve. So, how do you fix it? How do you handle being a victim of your own success? Well, you don't bet everything on one server, you build a whole team of them. And to manage that team, you need a director, a kind of digital traffic cop that sits right between all your users and your servers. And that traffic cop, that's the load balancer. So what is load balancing, really? You can think of it like this. Instead of having one super powerful, expensive server, you use a bunch of normal ones, a whole server farm, if you will. The load balancer is the manager of that farm. It grabs every single request that comes in and intelligently hands it off to one of the servers, making sure no single one gets buried in work. It's all about distribution and teamwork just to keep everything running fast. The actual flow is, surprisingly simple. So your request, you clicking on a link, doesn't go straight to the website server. First, it hits the load balancer. The balancer, in a split second, checks its team of servers and says, "Okay, you're up," and sends your request to the best one for the job. That server then processes your request and talks directly back to you. For you, the user, the whole thing is completely invisible and it happens in milliseconds. All you see is a website that just works. Okay, but here's where the magic really happens. It's in how the load balancer decides which server to send that traffic to. It's not just random. It uses a whole playbook of rules or algorithms to make the smartest call it can. So, there are a couple of ways to do this. The most basic way is called round robin. It's kind of like a dealer handing out cards, one by one. Request 1 goes to server 1, request 2 to server 2, 3 to server 3, and then it circles back. It's simple, but it's not always the most efficient, right? What if one of those requests is huge and ties up a server for a long time? Well, that's where a smarter method comes in, least connections. This one actually looks at all the servers and asks, who's the least busy right now, and sends the new request to that one. It's way more dynamic, and it really balances the load. And of course, the playbook gets even more detailed. Let's say you have a mix of powerful new servers and some older, weaker ones. Well, you can use weighted round robin to send more traffic to your heavy hitters. Or what about keeping a user's shopping cart consistent? You need them to stay on the same server. For that, you use something called IP hash. And if you want the absolute best performance, there's least response time, which looks at both how busy a server is and how fast it's responding. Okay, so we've got this smart traffic cop pointing all the requests in the right direction. But so what? What does that actually do for us? Well, it all comes down to 3 massive, non-negotiable benefits for any modern website or app. First, and this is a big one, high availability. Your load balancer is constantly doing health checks on its servers, like a medic on a battlefield. If a server suddenly goes down or you need to take one offline for an update, the balancer knows instantly. It just stops sending traffic there and reroutes it to the healthy ones. And you, the user, you never have a clue. For you, the site was never down. Second, you get this amazing on-demand scalability. Imagine that traffic spike hits. The load balancer can be set up to automatically spin up new servers to handle all that extra demand. And then, when traffic quiets down in the middle of the night, it can shut those extra servers down so you're not paying for them. This right here is a core idea of cloud computing, being able to grow or shrink to match demand perfectly. And third, a benefit that is absolutely critical today, security. Think of the load balancer as the bouncer at the front door of your club. It stands there and checks everyone trying to get in. This is a game changer for stopping things like a DDoS attack, where hackers try to crash your site by flooding it with millions of fake requests. The load balancer can spot that malicious flood and just block it at the door, so the real customers can get through without any trouble. Now, as you might guess, not all load balancers are created equal. Just like you have different cops for directing traffic on a street versus planes at an airport, you have different balancers for different kinds of digital traffic. The main difference comes down to which layer of the internet they work on. You can think of these layers like floors in an office building. Some balancers work on the lower, more fundamental floors, while others work way up top where things get more complex. And here's the key difference. A network load balancer that works down on layer 4 is like a mail sorter who only looks at the IP address and the zip code. It's incredibly fast, but it has no idea what's actually inside the envelope. On the other hand, you have an application load balancer up on layer 7. This one can actually open the envelope and read the letter. It understands the request itself. It sees the specific URL you're trying to go to. This allows for way smarter decisions. It can see you're asking for a video and send you to a video server, while sending another person who wants to see pictures to an image server, all within the same website. So, when you take a step back and look at the whole system, you realize this isn't just some random piece of tech. It's really the unseen engine that keeps our entire digital world humming along at the speed and the scale that we all just expect now. At the end of the day, every single time you stream a movie, or you jump on a huge online sale, or you use your favorite app, there is a load balancer working silently, tirelessly in the background to make that smooth experience possible. It really is the unsung hero of the internet, this invisible force that gives us reliability, massive scale, and a really important layer of security. It's truly a fundamental piece of our digital world. But technology doesn't stand still, right? With things like AI and new cloud services demanding more power and smarter networking than ever before, you have to wonder, what's next? How are these digital traffic cops going to evolve to handle the even bigger, faster, and more